This lecture was created by Danny Kessler, Associate Professor at Dongso University and Korea's first PhD in wellness tourism. Modern medical wellness is driven by a highly specific consumer demand. The objective is to secure world-class clinical intervention and serene, nature-based recovery within a simple itinerary. However, forcing these two experiences together creates a severe architectural conflict. This structural failure is known as therapeutic dilution. Consider the operational reality of a top-tier hospital. The environment is engineered for high-density patient flow, rapid turnover, and continuous intensive technological noise. Conversely, a premium nature retreat relies on the exact opposite metrics. It strictly requires low-density spacing, a slow cadence, and acoustic isolation to function properly. Looking at this diagram, the friction becomes visible. When developers attempt to force high-intensity clinical operations and slow-paced wellness seekers to occupy the same physical footprint, the environments repel one another. The clinical operations introduce noise and stress into the recovery space, while the wellness spaces consume valuable square footage needed for diagnostics. Both services experience a rapid degradation in efficacy and market value. The prevailing industry standard, the integrated all-in-one mega hospital, contains a structural flaw. It cannot deliver premium wellness due to this inevitable dilution of resources. The medical cluster in Busan provides a geographical case study that bypasses the mega hospital bottleneck entirely. The solution is an operational framework known as dual-modality design. Rather than attempting to balance competing needs under one roof, this framework dictates severe geographical decoupling. The high-speed clinical environment and the slow-paced sanctuary are physically severed, placed into distinct, specialized municipal districts. This visual comparison illustrates the contrast. By separating the fast data extraction from the slow recovery, both operational environments can exist in their pure forms. The sheer physical distance between these two districts functions as an operational firewall. It protects the quiet necessary for recovery from the mechanical intensity required for surgery. Spatial separation proves to be a strict operational prerequisite for scaling a wellness economy without corrupting the end product. The first operational node in this model is the Haeundae district, representing the fast clinical environment. Examining this image of Haeundae at night, the immense density of the coastal city becomes clear. This high-capacity urban infrastructure is engineered specifically to support massive volumes of medical traffic. Haeundae's specific architectural identity is categorized as a smart med city, heavily focused on clinical convergence. As seen in this photograph, the physical realization of this model involves massive vertical infrastructure integrated directly onto the coastline to maximize density. The primary resource being extracted and processed inside these towers is human biometric data. The district is dominated by rapid turnover procedures. Patients undergo AI screening, high-speed diagnostics, and acute surgical interventions in rapid succession. The architecture here is deliberately sterile and highly efficient. There are no slow-paced natural elements to impede the maximum throughput of data and patients. Haeundae operates strictly as a high-velocity data extraction engine, engineered for precise acute diagnosis, completely unburdened by the requirements of long-term recovery. Moving up the coast, the 𝗖𝗄𝗀 district serves as the counternode. This is the oceanic sanctuary. This photograph displays the starkly different geographical reality of 𝗖𝗄𝗀. The topography is rugged, isolated, and strictly low density. The operational methodology applied here is the formalized cohort model, relying entirely on long-term environmental healing. Here, the extracted resource shifts completely. Instead of biometric data, 𝗖𝗄𝗀 extracts and utilizes raw seawater for thalassotherapy. The infrastructure reflects this shift. The 𝗨𝗶𝗃𝗃 Center is built around massive marine recovery pool basins. Mechanically, the facility deploys over 90 underwater jets, each dedicated to supporting rigorous rehabilitation protocols. 𝗖𝗄𝗀's low-speed, expansive layout provides the exact environment of sanctuary that the high-density architecture of Haeundae structurally prohibits. This raises a clear logistical challenge. A health economy must successfully link two geographically isolated and operationally opposing districts into a single unified market. This map details the exact geographic relationship. A distinct coastal distance separates the Hyundai data node from the 𝗔𝗀𝘀𝘀 sanctuary node. To connect them, specialized transit corridors were constructed. These routes seamlessly transfer patients directly between the two operational nodes. This image of 𝗏 station demonstrates the heavy rail infrastructure anchoring this transit flow. It guarantees rapid deployment from the dense city center straight into the recovery zone. This system solves a critical temporal mismatch. The pipeline feeds a 1-day rapid diagnostic extraction process perfectly into a 7-day slow recovery stay. Information moves just as efficiently. The biometric profiles extracted in Hyundai are transmitted ahead to 𝗖𝗀, allowing the facility to customize the seawater jet protocols before the patient even arrives. Through this bifurcated model, operational friction is transformed into a highly scalable, sequential supply chain. Neither facility compromises its primary function, yet they act as one economic unit. To summarize, dual-modality geographic design acts as an operational firewall against therapeutic dilution. Hyundai manages the fast clinical diagnostics and biometric data extraction. 𝗖𝗂𝘀 manages the slow thalassotherapy and nature-based rehabilitation. This geographical split aligns with the projected requirements of the 2026 wellness economy. As global competition for medical tourists increases, the product must move past fragmented services. The standard is no longer an isolated hospital room or a standalone resort stay. The Busan model demonstrates a more resilient product, an end-to-end integrated sequenced recovery system. To maintain a competitive position in this evolving market, regions must transition away from single-structure megahospitals. Success requires building sequenced geographical engines that control both high-tech diagnostics and the long-term recovery finish. This lecture was created by Danny Kessler, Associate Professor at Dongsu University and Korea's first PhD in Wellness Tourism. Thank you for listening.